The topic of today's video is an electrical component that every electrical engineer should be familiar with, the resistor. This is Semblie, and welcome to our third lesson on electronics and PCBs. A resistor is a passive electrical component used to oppose or limit electric current. They are present in all electronic circuits. A few examples include the limiting electric current, voltage division, heat generation, matching and loading circuits, gain control, pull-up and pull-down resistors. There are two basic types of resistors: linear resistors and non-linear resistors. Resistors seen as linear further develop to fixed and variable resistors. Let's start with fixed resistors. As the name indicates, they have a specific value that cannot be changed. Here we have listed the most common ones, each of them offering unique specifications. Carbon film have high negative temperature coefficient of resistance, while metal oxide like to operate at higher temperatures. Wire round are precise, but at high frequencies they act as an inductor. Next type of linear resistors are variable resistors. These resistors are able to change the resistance value through a dial, knob or screw. The three most common ones are potentiometers, rheostats and trimmer. They are usually used for voltage division. Alright, that's all from linear resistors. Next are non-linear resistors: thermistors, light-dependent resistors and varistors. Starting with thermistors. A thermistor can either be positive temperature coefficient, which means the resistance increases as the temperature rises, or negative temperature coefficient. Resistance decreases as temperature rises, used for temperature measurements and circuit protection. Let's continue with light-dependent resistors. Resistance is dependent on light intensity, so they have high resistance overnight and low resistance at daytime, most commonly used in voltage division circuits. Ending with varistors or voltage-dependent resistors, whose resistance properties change with the applied voltage. They are very common and can be found next to screw terminals. They protect PCBs from high voltage transients. Beside the resistance value or electrical properties, the power rating is often the deciding factor when choosing resistors. The power rating of a resistor depends on its size. It is usually printed on the packaging, and for CAD programs it can be found in the description of the selected resistor. The power dissipation over this resistor is 0.9 watts, which means you need to pick a resistor with a minimum power rating of 1 watt. Here is an example of what happens if you pick a resistor with a low power rating. Resistors use colored bands to indicate both their resistive value and their tolerance, with the physical size of the resistor indicating its wattage rating. These colored painted bands produce a system of identification generally known as a resistor color code. Let's analyze this resistor. Starting from the side that has the most bands, the first band is brown, which is equal to 1. Second is black, which is equal to 0. The third band is the multiplier, and as we can see on the table, 10 to the power of 0 is 1. Which means this is a 10 ohm resistor with a tolerance of 5%. SMT marking codes usually come with the 3 or 4 digits. For both of them, the last number indicates how many zeros are being added to the first 2 digits. A 3-digit code has a tolerance of 5%. A resistor marked with a 4-digit code has 1% or less. Modern PCB assembly consists of two main methods for mounting components: through-the-hole mounting and surface mounting. Through-the-hole mounting is a process in which component leads are placed into drill holes on a bare PCB. Through-the-hole provides a stronger mechanical bond than SMT, making through-the-hole ideal for components that might undergo mechanical stress. Surface mount technology was developed to battle one of the biggest disadvantages of through-the-hole technology, and that is its size. Components are mounted directly onto the surface of a PCB and soldered on their pads. SMT allows higher component density, lower cost and faster production time. But take in consideration that smaller size also means a lower power rating. And that's all for today. Next time we will tap into capacitors and their usage in PCB design. See you soon.